welcome. Good morning and welcome to this ARPAS-UK CPD session on introduction to drones, including LiDAR. Michael, I think this is actually meant to be the aerial data capture one. You might want to just
start. No problem. That's fine.
I know there is a lot of crossover between the two. We are delighted that Michael May is able to be leading this CPD session, and as he has years worth of experience both within the drone industry and as a private pilot and generally within the aviation industry. This session is being run in conjunction with Connected Places Catapult, and we are delighted that we have been able to provide so many sessions on a wide variety of topics. If you do need to contact us, as I said, you may contact us either via email on membership@arpas.uk or via the website where there is a contact us button. In the meantime, I think we're going to, the session will be recorded, so please stay on mute and with the video off, and let's start. Michael, over to you. Thank you very much for taking the session for us.
No problem at all. Thank you very much for giving me the opportunity. As with all these things now, we're doing everything by Zoom and remote. It'd be nice to see some faces one day. But the only things that should interrupt us, certainly no fire alarms, Amazon, an overactive rescue Labrador, no fire drills, and hopefully it's not going to be a death by PowerPoint session. The whole idea of today's session is to give a realistic slant on what we do, using remote sensing, especially focusing on those things that fly, and give you the opportunity to feedback to us, ask any questions that you have, and we'll answer them honestly. I'll get straight through to the session. We're using real live examples of clients with their permission of actual scenarios and actual jobs that we've done, which hopefully will give you a little bit more context than just putting up this is a drone and this is the type of thing you can expect to see from it. So without further ado, I will keep sliding through these the slides I've used. We have experienced some issues with some people not being able to hear some of the video. Let's hear some of the video. That doesn't sound right, does it? Hear some of the sound on the video, and this session is being recorded, and you can play it back at your leisure. It might be that your streaming is not up to speed, or it might mean my streaming from sunny West Yorkshire is not up to speed today. But if there's any issues, if you contact Eleanor or myself, we'll certainly be able to provide you with the videos so you can watch them at your leisure. Don't worry about them. I'm sure people will let me know if they can't see anything. So what are we going to talk about? What are drones, UAVs, ARPAS, whatever it might be that they're being called at the moment? They change weekly, from not just from us within the industry, but the Civil Aviation Authority change what they want to call them. How do we use them? And I'm going to say the royal we. I'm speaking on behalf of ARPAS, but also Flythru, the business that we own and run, and summarise and give an opportunity for some questions at the end. Hopefully you'll find it interesting. Just a little about us. We've been running now for, I think it's our 7th year. 2013 we registered the company, so no, it's our 9th year. Good grief, that goes quickly, doesn't it? There were more people had been into space than had got drone qualifications with the CAA when we first started. Now there's tens of thousands of people doing different things with different drones, an ever expanding industry. We qualified before they were even NQEs and different things like that in the industry. It was very much in its infancy. The first drones that we flew had 2-axis gimbals, carry the GoPro, and could stay in the air for somewhere in a region of about 6 minutes. And now we're completely in a different world.
Michael, can I just interrupt for a moment? This is meant to be aerial data capture, not introduction to drones. I think we've got the wrong presentation here.
My apologies.
Don't worry. But as you can see, Michael has years of experience and clearly knows the stuff.
We should be back to a very similar screen. I'm just hopeful that you can all hear me again. My apologies for that. Where was I? Yes, we have both, they're now called occupied aviation. They used to be manned aviation qualifications, and now occupied aviation qualifications. Ben, who you can probably see in the bottom right-hand corner, has been flying for 20 odd years, flying models. He actually built the drone that's in the picture there, and was originally on the original Top Gear team when they first started flying drones, and the first drone pilot to fly the Shard. So we've got a heck of a lot of experience there, but things change literally weekly in this industry. And I think it's very important to note that the capture that the aerial data that we capture comes in various formats, but it's not about the drone. It's about the data that it captures. And that's what we're going to talk about today, capturing that aerial data, what we do in order to capture it, the type of sensors that we use to capture that data. We've spoken, if any of you have been on any of the other presentations that have been over the last couple of weeks, we've spoken a little bit about what the drones are and how they're classified. We have to obviously still comply with the Civil Aviation Authority's permissions for commercial operations, as they now call them, an operational authority. It changes on a weekly basis. And the payloads that we carry are vastly different depending on the type of data that we're there to capture. And we are restricted to, or the majority of people are restricted to line of sight still, depending on the area in which we're capturing data. And in the norm, restricted to that 400 feet or 122 meters ceiling of operations. Obviously, no restrictions indoors or underground, because the CAA don't operate in that airspace. Doesn't mean to say that we don't have to operate safely when we're within those as well. The type of data that we carry relates to the type of data that we obtain, obviously relates to the wishes of the client, and they can come in various types of scenarios, whether it's inspection, whether it's for monitoring, whether it's for post-incident or accident type of data. But we use a variety of drones to collect that data. And the reason that we use those drones is because of the way in which they can travel through the air, dependent on their speed, their height, and how long they're able to stay. At the moment, a lot of our work using inspection, RGB, red, green, blue, normal imagery, video, or stills is used capturing with one of these DJI M300 systems, simultaneously capturing, in this case, two different types of data, capable of carrying 3 sensors, but we tend to use it with 2. One's for position and the other one is capturing both RGB data, capable of zoom and up to 120 times digitally, and also simultaneously capturing thermal data, which we're able to interrogate post as well as see live on the screen. The fixed wings are primarily for capturing still imagery or video, obviously flying a lot faster and further. This system here, the twin mapper, we use a lot with highways because it's got 2 motors. The redundancy is certainly better. It can fly on 1 motor. It takes a little bit of flying, but we can quit the motors and we can glide this down in any sort of space. And I'll show you the type of environment that we were working in later in this production, the type of imagery that we're producing and why we're producing that. I think it's all very well being able to say this is the type of data that we can capture, but why are we capturing? What for? And I think if we don't know that when we're talking to our clients in the first instance, there's no point in going to to capture it. So many times we've gone into operations where the client has said, we want X type of data, we've gone and got it, and they haven't been able to either use it, understand it, manipulate it, or really actually it wasn't really what they wanted. So this system here carries a 42 megapixel camera. It will fly in around about 250 to 300 kilometers at one time. We don't obviously fly it that far away from us. It's a lot of it is crisscrossing sectors of land to create three-dimensional maps and models, collecting that data as we go. The smaller items that you may have seen on the shelf now in Curry's used to be in that Maplin's place when that existed. This is the latest of the Phantoms that come from DJI. They're a little workhorse with a 24 megapixel camera, capturing both video and RGB data. The only difference between either carrying this type of sensor and the larger M300 that I showed you earlier is that you're just able to fly further away from things. It's a lot more convenient. You can cover ground a lot more easily with the larger of the drones. These ones you're just flying lower and slower, so it takes more time, but you are able to produce a very good data set from this type of basic £2,000-3,000 system. It's not a toy. They were certainly marketed as that at the beginning, but DJI certainly have made a lot of money, and we've used them extensively especially if we're traveling long distances on planes, etc., where we're not allowed to take loads of high-powered batteries with us. Finally, LiDAR scanning, light detection and ranging is what it stands for. I'll go into the scenarios that we've used that and why we would use it, that type of data capture. And obviously, you're carrying a heavy load. This one is one of the LiDAR systems that we use. It's 3.8 kilos in total. This is on an M300. Sorry, it's not, it's an M600 hexcopter. And this would fly for around 25 minutes in reasonably stable conditions. Obviously, the more wind, the more it's going to affect the data as well. And the less time that you're going to spend in the air. What you end up with, if you don't know how to plan the flying properly, you end up with a lot of data that's captured very quickly downwind and stuff that's captured very, very slowly upwind. So one of the base things that we talk about when we go to any site is find out where the wind is coming from, and we fly crosswind everywhere. As it's moments with the fixed wings, because obviously they've got to turn into wind and not downwind. So there are certain things that you have to know beyond the fact that you can pick up a phone or a tablet now and press, that's where I want it to go. Wind is a massive consideration when collecting data, especially if you don't want blurred imagery, you don't want data that is taken beyond the capabilities of the sensor that you're flying with. So it's one of those things to consider when you're on site. You can't do it in advance. It's one of those things that you have to think about when you arrive on site. We also, as I said to you, it's not about the drone. It's about how do we get the imagery for the client that they need. The system on the left-hand side is a mobile handheld laser scanner. We mount that to boats and buggies and the ends of poles and anything that we might be able to put where a drone can't get, and the client wants to get 3D data. Again, it's a matter of being able to understand data sets, how you can merge those data sets and understanding what the client wants at the end of it. If the client simply wants to go and see the condition of something, why are you offering him LiDAR and all of the other 3D mapping techniques when he really just needs a video? He needs a very good video, and he needs to be able to see and interrogate it afterwards. But it's about making sure that you've got, it's horses for courses. What does a client want? How do they want it? In what format do they want it? all decided before you even think about the type of drone that you're going to be able to deploy, whether that's a drone as in a buggy, or it's a floating apparatus, or in probably 75 or 80% of the cases that we use a flying one. What are they used for? And what is the data used for? And try and show you how this data is collated. It's used to supplement and enhance the conventional surveying techniques, or photography techniques, or video techniques, or obtaining data, whatever that might be. It increases safety. Why would you put a helicopter in an area where you've got people underneath you when you can put now a 249 gram drone? If it falls out of the sky, it's not even going to give you a headache. The cost is ridiculously cheap compared with the running of a helicopter for the day. If you look at the website for the National Grid, they will show you how many millions of pounds they still use to this day, flying helicopters down all of their power lines, and it works out at something around £1,900 an hour net to run their helicopters. They're running them 8 days a week. That's before you start putting a pilot into one of them. So just in maintenance and fuel, that's what it's costing them, just shy of £2,000. Increased fuel price, as we've all seen, that can certainly go through the roof, £500, £800 a day just in those variations. So it's very difficult for them to budget. The speed at which we collect data is comparable with occupied aviation. The way in which it can be viewed without sitting in a helicopter, you can now remotely view a live video feed from a UAV over Wi-Fi. So engineers don't even have to leave their office. They're able to direct the operations from a desk. With the advancement of drones that are being used to certainly remotely now, so you'll be able to go remotely, send up a drone, and it's being almost fully autonomous. Those things will come. They'll come in the future. They've got their issues at the moment in terms of making sure that everything on site is fully safe, and you're able to take control if necessary in the event of something going wrong. But the days of autonomous inspections and flights and above and beyond the standard, look from above security is not far off whatsoever. Again, got to reiterate, it's about the data it gets. If the data isn't available or useful, it's absolutely no point in deploying anything. It's about finding out what a client wants. So what data do we collect? It's not limited to this, but certainly photography, as normal, just taking an image of something, we thought was on its way out, and three-dimensional data collection was going to be the majority of work we do. It's now actually coming back, and it's quite often the requirement of somebody who is inspecting something and is wanting to just purely view the integrity maybe of a structure, that they want a very good picture of it, and they want to be able to have a look at that picture in post. But they certainly just want, that's all they want. They don't want a 3D model. They don't want anything beyond that. So we do more photography than we ever thought we would do, maybe 2 or 3 years ago. Videography is just lazy photography, if we think about it from our perspective. When we're looking at structures, quite often the client will ask us if we can just take a video, and they'll take stills. Maybe we're running at 35, 40 frames per second. They're able to interrogate that sufficiently in order to get a good idea of what their good idea of what their structure may look like, and how they want to plan any maintenance or anything further from that. So photography and videography are certainly up there. We don't do a lot of the nice video, the stuff that needs, the stuff that you will see on Country File and that type of stuff. But you can see, just watching TV, every program has some sort of drone footage, even the Great British Bake Off. We use thermal and multispectral imagery. You can see thermal down in the bottom right hand corner of the slide just here, where we've collated measured data that looks at hotspots, cold spots, and tries to help with the maintenance of solar array. In this case, solar arrays. We'll see another idea of how we use and collate thermal imagery later in this session. Multispectral imagery. So basically, the stuff that the eye can't see. Used a great deal in agriculture. When we look at grass, we think it's green. When you really look at it, using the multispectral sensors that we carry, you'll see that there's a great deal of difference between one green and another, looking at how some crops are performing and how the science behind fertilizing those crops, or where they're planted, or the times and the dates. Drones are now used extensively by farmers, just to look at the condition of their crop and how it is, how it's grown, and in a lot of ways how we're going to be able to become more carbon neutral in the way in which we farm, and how we can still maintain the productivity and the low cost of the crop that comes out of it. Everybody wants to be efficient. Everybody wants to be carbon friendly and friendly to the environment, but there's always that back from the Tesco's and everybody else that they want a lowest price as well. So it's how do we achieve that? And using multispectral imagery, we're able to look at the condition, if you like, of a crop, look at the condition of a field, look at where it can be improved. LiDAR, which is light detection and ranging. Everybody thinks it's laser. It's not. It is a laser, but it's a laser. It obviously is a light beam. Everybody's heard of probably sonar and radar. So what happens with radar, with those beams that are those sound beams that are sent out, you're detecting the intensity of the return of those to try and build up a picture of what is out there. Sonar, the same, underground, measuring that intensity of a return of the sound waves that are being emitted, and those coming back to find what may be either another vessel underwater or a structure. And LiDAR is very much the same. It's measuring the intensity of return of light from a laser source, firing out between 700,000 and 1.4 million times per second in terms of the sensors that we carry. We also go underwater, so we carry multi-beam sonar as well, again creating that 3D picture from top to bottom. I'm going to do some illustrations of all sorts of ways in which we've captured data and what that data has been turned into. But just for example, planning, pre-construction, construction, inspection. We've gone from finding clandestine burial sites of honour killings. We've found the bases of Nazi encampments on Alderney, right the way through to taking images of beautiful houses and the like. But just hopefully this will give you a varied idea of the type of data that we collect and why we collect it and what our clients use it for. The first one, there is a video I will, unless Eleanor interrupts the video and tells me that she can't hear it, there's a video playing. I make no apology that was made by one of our suppliers. So it's based on Routeseeing, who are one of the suppliers of one of the LiDAR systems that we use. But it's a good idea to show you the type of environment that we're working in. We're next to a road, we're next to a coast, we're next to a busy bridge, but also we're trying to penetrate vegetation and collate data so that people who are wanting to plan a cycle route are able to do that accurately and cost effectively. So this was the area that we were originally asked to map. You can see in front of you, it's the area in blue. It's a cycleway. It explains that in the video, but I'll run it for a minute or so to give you an idea of what we were asked to do. Or maybe I'll tell you first. Scan and report on the proposed route. It has its problems of dense vegetation, existing highways. Had to do it at low tide so they could see what the rock and the formations were like at low tide, and whether they were going to be able to build a structure that would rise above that. And we were going to give them a digital surface model. So if you think about those of you who aren't au fait with surface and terrain, we were asked to look at the actual surface of the land rather than give an image that a photograph might take. So we were asked to strip away the vegetation in a model to give to the client, and then to improve upon the contours that they had from existing maps, and we go down to 10 centimeters. We were actually able to create a 1 centimeter contour map from the information that we collated. But this will give you an idea of what we did. Hopefully you'll be able to hear it. If you can't, we'll give you a link to it in the future. So Flythru started 6 years ago. Ben, my business partner, was a hobbyist, and I'd flown light aircraft and helicopters.
At the moment, we're working on a project for a cycleway, which is linking 2 existing cycle routes.
And we are going to assist the council by creating a digital service model using the LiDAR system. LiDAR has given us another string to our bow. It's another mapping technique that complements photogrammetry, and in some cases actually replaces it. It's probably grown our business by 50%. The LiDAR pod has been great for us in terms of its penetration of vegetation. 90% of the work that we get is about the data that can be acquired in difficult to reach, heavily vegetated areas. I think that we were surprised at the amount of points per square metre that we were achieving through dense vegetation, not just in winter but in summer.
The support along the way has been fantastic. Any on-site problems that we've had, technical or hardware related, we've been able to speak to a technical assistant very quickly on the phone.
Our LiDAR system's used 2-3 times a week now. The surveying world has accepted the UAV LiDAR and its outputs, and we're getting more and more instructions. The relationship we've got with Routeseeing. I don't want to keep going about the relationship we had with the client, because that became a little bit too much of a sales talk from them. But we're collecting LiDAR data there in an area where the Environment Agency had LiDAR data collected, and it simply wasn't of sufficient detail that anybody who was looking at doing any planning or constructing would be able to do that. So there are maps available free from the Environment Agency that collect LiDAR, just like you would maybe go on to Google Earth and look at something in quite a bit of detail. But when you really interrogate that data, you get to a point at which it starts to become pixelated. I'm not talking about the pedestrian stuff where you're looking through people's front windows and everything, but when you're looking from above, it starts to become pixelated. And the fact that we're using UAVs, all we're doing really is supplementing that data and flying something that's lower and slower, so that we're able to collate, in that instance, 400 points per square meter to identify and join up to create this 3D contoured model, where the data from the Environment Agency was around 3 or 4 points per square meter. So you can see the difference there. You're not going to be able to use that data for anything more detailed than that's it, that's what we've got. There's an overview of what is there. It's just simply not good enough or accurate enough. And previously, it would have been surveyors on the feet with a big pole, walking through dense vegetation, taking weeks to be able to collect the data. That took us 1 day of placing of ground control using surveying, standard surveying methods that we could then tie the model into and create what is an accurate model in the world rather than just in its own right. And then 1 day of flying. The client had the data processed within 10 days. So this is the second way in which we collect that. What do we do? Where we've been asked to look at an area by ecologists on this occasion. So they wanted to, they had been approached by a local council who had been approached by a builder saying that they wanted to put 300 houses on an area of land in out on the outskirts of Coventry. And there were concerns from the environmentalists that there were lots of mature trees there and that they didn't want them all knocking down and having an impact on the environment. So taking photographs of trees is okay, but what you basically get is the picture of the nearest thing to you, which is the top of the tree, the canopy. So if you can imagine when you're up with a drone taking images from above, all you're doing is taking the picture of the top of the tree. You've no real idea what's going on underneath it, nor can you see. However, it's good to get that idea of the tops of the trees, because it gives you a clue as to the maturity of those trees and how they are growing and their position. But also supplementing that with LiDAR, you are able to ask the very clever software to strip away some of that data that they can see and give you information that you would not be able to get from the pure photographs. So what happened was that we flew this area and we were asked to target trees of 9 centimeters ish or above, so that those could be treated as to be preserved, and information that could then go back to the client to make a decision as to whether they were going to build on this land and whether it was going to be viable for the builder or it was going to be not, and whether or not it was just purely going to be left as a piece of land that the community could use. So in your own time, you'll be able to see this a little bit better than probably you can now on the screen, but each one of those dots represents one of the trees that was on the land. You can see that we've got some of the more mature canopies in dark green, and that we were able then to go to the client working with arboriculturalists, which takes some saying when you said it the first time, and identify those trees that should be preserved. It was then quite obvious from the map that we had done, and this took us an hour and a half of flying and probably a day of processing, that the council were then going to go back to the construction company and say, we want, and they said they wanted certain areas to be preserved, and you can see those on the diagram. Areas of maybe you can see my pointer being moved across it, but the perimeter areas and those avenues, which sounds very poetic, of trees that were asked to be preserved. It was then decided 3 months later by the construction company that they wouldn't be economically viable to build the amount of houses that they wanted to with those preservation orders, and that remains an area of green space just outside Coventry. But giving it another idea of the type of data that we collect, it's still LiDAR data like we were doing for the Connell to Dumbeg cycle route, but the use is completely different. It's having that unblinkered approach to what the data that can be obtained and why you would obtain it, and what is going to be the end use. The third out of the four scenarios I'll show you was a glass walkway that was going to be built by the Edinburgh County Council on the site of an existing walkway just outside Edinburgh on the River Almond. And we had to think about how we could combine different data sets to give them what they wanted. They said they wanted the most high resolution, accurate model they could possibly create of this area so that they could use it for construction purposes. So we worked with a survey company who got very wet and decided that they were going to laser scan the rock face. And then we supplemented that laser scan data with photography, photogrammetry, and LiDAR, creating a 3-dimensional model. So first of all, targets were placed on the face. You might not be able to see, but I know where they are. There's in the distance, there's a white target. And we scanned the rock face from the center of the river and from the far banks to give that 3-dimensional model of the existing rock face as it stood. We then supplemented that with both LiDAR and photogrammetry from above. Took 2.5 days to do this. It's about 450 meters, 500 meters long. But again, done in 2.5 days, and the client gets the results within a couple of weeks, rather than almost impossibly having to use people with rope access to gain the measurements and get the information that they need. And these are two of the outputs that were produced. The interesting thing was that we compressed nearly 20 billion points of data that we collated in 2 days. When we handed this to the council, they hadn't got a computer within the council that could actually run it. So when people ask you for the highest resolution and highest accuracy you can provide, you have to be able to make sure that they can view it and they can manipulate it and they can work with it. Because on this case, we had to take our computers to Edinburgh Council and assist them with their planning department and their engineers to view this in 3D. If you look at the left-hand side, that's not a single image. That is a photogrammetry knitted together mosaic of thousands of images, which create that 3D look. You can see that there's points of data missing in the middle. The black bits are where water is, because there is no point of reference on water. It's a moving stream, and the photographs can't link one photograph. Sorry, the software can't link one photograph to another to create that imagery that's required. But you can see the green dots at the top of your image with the lines coming off them in triangles. Those are the fields of vision for that image, and those images are taken at those geolocated points. So each one of those can be interrogated as an individual image, but also as a 3-dimensionally created model. And looking at it from a slightly different angle, the LiDAR imagery, which is the other the other image, which starts with the orange working down to the blue, is the same area of land from a different direction. What we've done is we've asked the software to remove the vegetation and give us a 3-dimensional point cloud. What we've done is we have colorized that by the intensity of the return back to the LiDAR system. So obviously it was nearer where it's orange and further away where it's blue. And that creates our 3D model. And if you can, what you can see there is the existing walkway, which runs from over in the east, and it wangles its way around the top of that, that escarpment to the right. And an existing non-formal walkway, which is just further above it. And those had never been seen, never mapped, ever by anyone. It's just a line drawing at the moment on an OS map. So they were able to view what they wanted to and try and quantify the amount of cost it would be to create this new glass walkway above the River Almond, yet to be built. And certainly, I think COVID had its impact, and people are still using the existing cycleway there. The next task was was using photographs to try and quantify the amount of material moved across the site on the A14. If any of you have worked or driven up and down the A14 or the M11 going north, there's been an area of about 20 kilometres sort of from Cambridge beyond Swavesey and up that way that links up to the A1. And there were borrow pits which they were using to take material to assist them in constructing the new road. And these borrow pits were around about a kilometre square and somewhere in the region of 15 metres deep. So you can imagine the amounts of material that were being used. This material was obviously having to be shipped by road to various other places on the site. And the quantity of that material was being measured from the imagery that we provided. You can only imagine a 14-kilometre route that would normally, you're going to measure that by a guy or girl walking and taking measured points, how long that would take, and also a pit that's a kilometre square, 14 metres down with machinery operating in it and around it at all times. We were able to, in the summer months, not winter, but the summer months, do this in a day and give them detail of the 750 hectare site, which they could then use to quantify the amount of muck that they would have to shift from one place to another. They estimated during the 2.5 years they were on site, they saved over £1 million just in higher cost of machinery and plant that you realise they wouldn't have to use to move this vast quantities of material around. And we used the fixed wing, and we'll show you exactly how that worked in and around people working. So what I'll do is, if you can see what's going on in this, we've got the existing A1M, well, it was restricted to 40 miles an hour. We've got dumper trucks, we've got a crane lifting, we've got 2 excavator machines, and that's just in the foreground here. And we were able to work with these guys, giving them briefings. The first time they saw it, saw the machine flying, it was, everybody was interested. By the time we'd been there for nearly 2 years, nobody gave a monkeys what we were doing. They just knew where we were, asked us where we wanted to take off and land, and we worked around everybody that was on site, just collecting photographs. But it gives you an idea of how the restricted area in which we can land one of the large planes. Guys on the left of the image as we flew actually stopped for us to land. I mean, it's an amazing place to work. But in and around these guys, when we first went, trying to, everybody was thinking it was going to be dangerous and impossible, but it certainly wasn't. And it just proves how accepted they are now by the construction industry. And this is one of the 3D models that we produced. You can see there are various pits and structures. The surveyors were able to do the quantification from that to, you know, we were down at 1.5 centimetre accuracy on the ground, so that their volumetric analysis was plus or minus 4% of the actual material that had been moved, which was phenomenal. They were certainly a little bit opposed, I think, to using UAVs at the beginning, but when we'd saving the money that we did save them, they're used extensively now by these guys who ask us to come and do the volumetric analysis for them. The majority of work that we spoke about is inspections. These are the types of structures that we're asked to inspect on a regular basis. This is one on the A11, I think. The weird thing is, where this bridge was built, and you can see in the foreground there's fencing around the bottom. They've now built houses around this, and it's impossible to get to the bridge. You have to climb over a fence at the back of that industrial estate in order to get there. And originally they were inspecting this using MUPS, mobile platforms. It's impossible to do it now. So we now fly these by drone, man lifted over fence with the drone and with an engineer, and we fly these. The types of images that they ask us to collect are the ones that are shown here. One is the wide normal image that we take. The other is the slightly more focused zoom, but we haven't over zoomed this. This is purely taken from a video, so it's taking simultaneously a wide angle, a more zoomed photograph, and also thermal at the same time. They just can't get to these. It's impossible at the moment. So we're able to provide that. They simply go onto their PC or their laptop or their software in which they're recording all of these inspections, zoom in, and look at the integrity of in this case, the bearing that's holding the load of the bridge. Another bridge in the middle of Colchester, which was impossible for them to do in a boat. The tidal extent meant that when the water was running beneath it, it was too quick and they couldn't anchor a boat to go underneath. And when the tide had gone out, so there was that lull of an hour, you know, between low and high tide, it was so low that you couldn't put a boat in there because of the silt, but the silt was too deep for somebody to walk through. So now they use a drone to be able to examine that bridge. And whilst examining it, we were asked to look for any thermal anomalies along the bridge top itself, which we found. And when we traced that directly upwards, there was a patch of tarmac that had been used to patch the footpath, which was basically leaking water through. And they were able to see in one single image and geolocate that. When they panned out, they could see exactly where it was in relation to the patch on in the surface of the bridge itself, and do that very small minor repair to get rid of the water ingress. You can't see there's water ingress from the picture on the left hand side. These are simultaneously taken images with the same camera. So it just shows the type of thermal data that we could use. We've used it for the tops of electricity pylons, and they've seen there's hot spots, low spots, arcing, as well as this type of very, very simple structural integrity issues that we find with thermal. And I think, the final part before I actually finish, we're creating now a three-dimensional world that has never, ever been seen. So when this bridge was built in the 19th century, and it's just been added to make it, more structurally sound and have some concrete pillars put in, nobody has actually got a three-dimensional image of what that build is. There was the original build, which was done on a very big drawing, and a smaller build, which is kept in some sort of computer-assisted file. But we were able to create a three-dimensional drawing of exactly what is there using multi-beam sonar, using laser scanning, using photography or photogrammetry and LiDAR above to create a model that's not been seen before, which sort of quantifies the assets that somebody has. This is Essex Highways, who we work for and inspect their bridges. And finally, confined space. So going in somewhere where data is wanting to be acquired that could be anything. So in this case, this was purely video and photography. We also take thermal imagery at the same time, but this is an Helios drone that we use. This is the White Cliffs of Dover, Folkestone above. This is on behalf of Network Rail, where the main train line, if you were to go 70 meters inland, the main train line going through to the tunnel runs across the top, and basically this land is slipping towards the sea. And they wondered what's wrong with the drainage adits, and we were able to find out, and this is real time. So the drone is horrible to fly in the outside. We pumped out a lot of the water, or Network Rail had pumped out the water for us, and then we went into the drainage adit. Now, this drainage adit was modified in the 60s and lined, as you can see. I hope it's not making anybody feel sick. But we were able to do some very base calculations. If you can see those ridges of the tunnel, we were able to count those and tell them within centimeters of exactly where the issue was that we found in this adit. Everything seems absolutely fine as we go through to this point, but at the moment we've been running literally in real time, less than 60 seconds to then finding out that there was a little pilot error and knocking a wall. But these are a cage drone, and that's the whole idea of these, that we're able to, I'm not saying bang around, but be able to fly those in areas where we're not bothered about the hitting the props on a wall. We've gone around a slight bend and then met with a collapse showing the breach there. We hovered there for a while, took a number of photographs, but were able to give the engineers a breakdown of where it was and how it had occurred in less than 2 minutes. They were watching live with us. We're able to then move on to the next session, and to provide them with a series of stills that they were able to work from and make recommendations for what they would like to do. And finally, this is the same area. You will see across the top, there's the Folkestone Calais Railway, which actually says Folkestone Calais on it, if you can see that, which runs there. We were down on this part here, and this was these areas of slippage. The tunnels run from right at the far end. At the top there, you've got the Battle of Britain Memorial. So, nobody wants any of this to slip into the sea, but this was a combining of all the data sets. So there's LiDAR, photogrammetry, laser scanning of the portals, and the video that we took within the tunnel to create something in 3D. Each one can be interrogated independently. Each of the bits of data can be combined as one, but it gives you an idea of the types of data that can be collated from flying, floating, underwater, but and just I don't know, an insight into the type of things that we do and what our clients want. We're currently today we're doing a coastal erosion survey up in Scotland. We're mapping peat bogs in Doncaster. The way in which people are asking for data now from the sky is unbelievable, and hopefully that gives you an idea of the types of data that we can collect. Not just us, but anybody who is out there that can collect, who's got some idea of what they're doing. The UAV world is ever expanding. The technologies are leaping forward. You know, we're carrying 100 megapixel cameras where we were carrying 12 megapixels when we first started. Surveyors are now, you know, realizing that there is a great value to the data that we can collect, and it complements their techniques. And in some ways, it actually enhances them, because they were never able to collect that much data previously, and able to use it in the way in which it can be used now. It's quick. It's a lot safer to put a drone in some places than you certainly wouldn't want a human, but not to be taken in isolation. It's still not about the drone. It's about the data it collects and what the client is using it for. If you've got any questions for me, or if you've got anything, I'm quite happy to take the questions now.
Michael, we do indeed have questions. First of all, thank you very much. That was extremely comprehensive. Thank you. So our first question is, this is an exciting technology application. How do accredited operators get trained, and what are the professional steps to take for accreditation?
Right, so two ways. I'm going to back some of it back to you, Eleanor.
Yeah.
Eleanor's got, obviously, she'll have a list of accredited trainers that will give you your first steps. And I'm not going to be cruel. It's just like learning to drive. You know, once you've gone and passed your test, that's great. It doesn't mean to say you're the best driver in the world or the best pilot in the world. I think it is very exciting, and you can go out there and go and get qualified to fly one of the systems. But it's about knowing what you're doing and how that data is going to be used, and how you're going to acquire that data. So the first steps are to go to one of the guys or girls that Eleanor will be able to recommend through ARPAS, because they're the professionals who are not only recommended by those guys, but also qualified by the Civil Aviation Authority to be instructors and to give you a qualification. And deciding what you want to actually achieve before you do it. If you want to go and take some lovely photographs, or you want to maybe do a standard inspection of a roof, for example, great. You're going to be able to do that relatively cost effectively and safely. But it's just like getting into any I suppose any qualification. You're starting at the bottom and you're working your way up, and affiliating yourself with all of the forums, with people like ARPAS, looking on the forums, seeing what other people are doing and learning is certainly what I would recommend.
So Michael, to go on from that, I've just added a link to the ARPAS-UK website, where we have training companies who are also ARPAS members. A number of them do actually provide discounts on training if you are yourself an ARPAS member. So it's always worth having a think about membership. My little there are numerous other advantages as well, including discounts on kit and training and insurance, as well as access to a network of people who can help advise. So that's probably the first. And the next question is, how do we find professional operators? Is there a register? That actually leads on nicely. Again, on the ARPAS website, we have a find a member map, and that will show people within. You can look by postcode, you can look by town, and it will find people in your area. Alternatively, do please email us. We are very happy to send on information to all our members. We're completely unbiased. We send it out to everyone. So sometimes if you're a drone insurance member, you might get information asking you to see if you'd like to apply for a job or tender for a contract. But everyone receives the same information. Next question. Are professional bodies such as TSA, so RICS, CISIS, partnering with the drone industry? Michael, do you want to take that one?
Some are. We've had, I was going to say that originally, there was a lot of the organisations and professional bodies that were standoffish in relation to partnering with drone providers. But as soon as some of the larger organisations and utility providers started to use them, then more organisations are looking to affiliate themselves. You get a lot of work through network rail infrastructure people like that, rather than organisations. I think that, you know, you get organisations like RICS, like ARPAS, like any of the other. They tend not to affiliate. They tend to allow you to become members now. The construction CSCS in construction, you know, you're now allowed to become a member. You're now allowed to get the qualifications to go on site as an operator of a UAV. So yeah, I mean, lots of organisations are starting to accept and allow membership from people in our trade, and it seemed to be one that is certainly accepted.
And I'll add to that as well from the ARPAS side of things. They're absolutely TSA, RICS, CISIS are partnering with the drone industry, in many respects via these CPD systems, as well as on their member services and via GeoBusiness and other events. So we're always very happy to help coordinate, and what our main method of working is via collaboration with such people indeed. So the next question was, how did you get started, Michael? What's your background? Does it suit ex-military? Can surveyors train? That's multiple questions there for you.
Gosh. It's difficult. It's difficult. How did I start? I went with a guy. I flew helicopters. I've got a helicopter license, and I went to an event 12 years ago where DJI were flying a little Phantom around, and the guy I was with was the helicopter pilot for the police, and said, "These are the future. They could fly lower and slower, not disturb a scene. You ought to get into it." So I went on a course down in Heathrow and bumped into a guy who's now my business partner. So we came from diametrically opposed places. I was a commercial director of a business, so I knew how to run a business, sort of. I had an interest in flying. He could build UAVs, so we were complementary. Ideally, if you are doing this, you need to have some sort of motor skills in able to fly. You need to, but it is, you're able to learn quite quickly. There's a lot. All I would be definitely saying to you is, don't believe everything that the people are selling the drones say to you. It's not a matter of unboxing it, plotting it on a map and flying it. Doesn't tell you about wind, doesn't tell you about speaking like I have this morning to the police, 2 prisons and an airport. It doesn't teach you about putting ground control in using survey equipment. It doesn't teach you about how to comply with network rail rules and procedures online and offline. All of those things are things that we've had to learn on the hoof, and that if you get with a decent training organisation, they'll be able to point that out. So get trained properly and go on a course. It's not going to cost you a fortune. You'll soon find out if you like it or not. But it's not just, I am ex-military as well, but it's not just ABC. It's A, and there's quite a few little bits in between before you get to B, and then you might have to go back to A. So if you're an ABC person, no, I wouldn't say it's for you. I would make sure that you have a go and fly something, do it as a hobby first, go and buy something for 250 quid, play with it within the law, and then decide that you want to have a go at it. And yeah, it's a great industry to be in.
Sorry, apologies, I was muted. That appears to be all the questions so far. If anybody has any more, please do pop them up now. Otherwise, I will draw the session to a close. Thank you very much, and thank you for being patient because we've overrun a few minutes. As I say, do get in touch via membership@arpas.uk. And Michael's email is michael@flythru, FLYTHRU.co.uk. Thank you very much indeed for attending this session. Don't forget there are further sessions happening over the next 10 days. So do have a look at those. Thank you very much then. Goodbye.
Cheers.